My name is John Stoltz. I work for the LMG kernel team. And we're going to talk a little bit now about AOSP Devboards and some recent future pain points that we've had with them. So I guess last year at Bangkok, I got to give a talk about the HiKey board being accepted in AOSP as a Devboard target. So now here we are a year and a half later, and we've got two of them. We've got the HiKey still supported in AOSP, but relative to modern phones, the HiKey is now sort of a fairly low-end device. But we also have now the HiKey 960, which is basically a flagship device. And so this is really exciting. So we've got a bunch of technical details on the differences. If you're looking at the HiKey 960, it's basically HiSilicon's flagship SoC. It's a big little design. It's got more memory. It's got more storage and faster storage. It's got vaulting-capable graphics, PCIe, and faster everything else. It does come in at a steeper price, and this has caused some grumbling out in the community. But while it's not kind of an instant purchase sort of thing like Raspberry Pi, it does provide a lot more interesting functionality because the performance profile of a real flagship. And so for Linaro and when we're doing development, we want to be able to target devices that our members are very interested in, that Google and others, when they're looking at real devices. And so this provides that performance profile that's useful for development. As far as the out-of-tree patches for both of these boards, with HiKey, we're basically finishing things up. We've got 3 USB patches. I hope to go in through the stable tree. There's a hack at the moment to revert the ion ABI change that landed in 4.12. And that's basically just there at the moment until we can get AOSP to support the new ABI. And then, of course, the Mali GPU, which can't go upstream. For HiKey 960, it's basically early days. The HiSilicon landing team did a really great job starting to push patches upstream even before the board was announced. But we still have to kind of basically start over, so it's still a fair amount of work. So everybody probably knows 96 board stuff at this point. So basically, it creates kind of this hardware standard for different SoCs. And the key part is basically having these different peripherals that we're able to mix and match on top. One that's particularly interesting for AOSP is this neon key. This provides basically what is a sensor hub that's seen on a lot of different phones these days. And this is a little microcontroller connected to a bunch of different sensors. And so it's able to collect data from all those sensors continually even when the phone is asleep. And so this is a really nice mezzanine to have in order to kind of get something that's more comparable to what we see on real phone devices when we do our development. The other thing is this was actually developed in collaboration with Dimitri at Google, and so it's very cool to have. So why do having Devboards in AOSP matter? So I've talked about this a number of times. I guess before we had HiKey and AOSP, if you wanted to do any Android-focused development that you also were trying to get upstream, sort of your best device to kind of pick for this was something like a Nexus device. But quite often, when you got something like the 2005 Nexus devices, or 2015 Nexus devices, they were shipped with a kernel that was almost 2.5 years old. And so this meant that you could maybe develop the feature, test it in Android against this older kernel, but then you were forward porting to mainline, trying to push those patches upstream. The maintainers would want to change or something, make those changes. Hopefully it's fairly easy to go back to the older kernel, make the similar changes and validate it. But to some extent, the things that you're actually testing on is not actually the upstream kernel that eventually the code would be going upstream. And so that was problematic. Even with the current generation Pixel, when it was released, it was almost 2 years old with the kernel at that point, which isn't great. Now, if we look at vendors who move to kind of the newer kernels the fastest, we're still looking at about a little over a year. And to some extent, when you break it down, it makes sense because they've got to bring up an SoC, they've got to work out all the bugs, they've got to productize it into an actual phone device, and then there's also the whole other non-kernel software stack that has to be dealt with. And so, this is somewhat understandable as far as the time frame. Now with HiKey, the cool part is that we were able to, after we announced it in AOSP last year, we were able to move to 4.4 pretty shortly thereafter. And basically we had this out more or less a year before the first flagship came out running 4.4. And so, this is cool because we had this board that was out there and open, people could hack on pretty early. But it's also cool because, obviously the folks who are working on those phones, they have their own internal dev boards that they're probably bringing up probably at the same time that we were doing the work on HiKey for 4.4. And in one case, we had one vendor, they came across a problem with the C group migration performance that they saw with 4.4. And they were able to raise that issue through Google, and then we were able to kind of reproduce that issue on HiKey for 4.4 and go to the community and say, hey, we have this problem. And then instead of having to come up with a solution ourselves, the maintainers said, oh, that's a regression, and they fixed it, and we're able to validate that fix and get that pushed back into the stable tree. And so this was, really useful because it's a thing where those dev boards that those vendors are working on are very proprietary, very, you want to be a premier partner to be able to get a hold of them. But, HiKey basically gives everybody the ability to get one of these boards. Now we moved to 4.9. I guess February this year. And so this is kind of cool because in some ways, we really get to be pretty far ahead. If you look at the current Pixel phone, we're now 2 kernels ahead. And if patterns repeat themselves, probably we'll start seeing devices on 4.9 show up in spring of next year. Now, this is basically the same data, just kind of in more of a latency graph way. And kind of the more interesting part is if we focus on just this little 2-month delay here for 4.9. Now, I guess a couple years ago, I went and talked to plumbers about issues we were having trying to upstream patches from the mainline, or upstream the Android common patches to the mainline tree. And one of the issues we were having was that we would, take a feature from the common tree, forward port it to the upstream kernel, work with the maintainers, they'd want changes, we'd change it, we'd push it in, and we just kind of hoped that it was good enough. And we'd wait a couple years until Google and other device manufacturers started using those kernels to see whether or not it worked. Sometimes it did, sometimes it didn't. And the root of the problem was the fact that when we look at devices, these are basically SOC trees. This is a crazy amount of code that is on a tree. This little blue bit is the common part, which this is the part where we're really working hard to upstream. But it's really a teeny piece compared to the huge amount of code that was in the devices. And so really it was, the bottleneck wasn't so much on the Android common tree, it was trying to find a device that we could use upstream. And so with HiKey, the picture's a lot better. So even if you look here, the shortest line here is somewhere around 300,000 lines of code. And with HiKey, with the 4.9 kernel as of July, it's a little over 100,000. And so this is a lot easier to be able to move forward to newer trees. We can kind of move this along very easily. Still, it's kind of a little surprising that the device-specific code is more than the Android common tree here. And so if you look at it in a little more detail, it's mostly because it's the Molly driver. It's one of those things where we can't do too much about it, but it's, to one extent, the Molly driver is a little more isolated, so the Android common patch that does have more subtle interactions with the rest of the kernel. And so, even though it is kind of larger in size, moving it forward isn't as complicated. So the interesting part here, again, with that 2 months is that we actually have been keeping HiKey running against mainline for all the kernels, in between 4.4 and 4.9. And so actually the day that 4.9 came out, we had HiKey already running on it. It wasn't a problem. And actually that 2-month delay was the time that it took to move the Android common patches. There's also holidays in there, but basically for moving the Android common patch set from 4.4 to 4.9. And so it's kind of neat because this shows that, the critical path, I guess, has moved from being devices back to the Android common tree. So that can be a spot where we can kind of, refocus our efforts in trying to upstream that tree. Now, before I paint too nice of a picture of this, there isn't, magic to these dev boards. It's not just by being a dev board, this easily, these short little bars show up. When we look at the HiKey 960, basically when we shipped that in April this year, we released with a vendor provided kernel, basically, and so we have similar, latencies, I guess, as other flagships released around the same time. And moving that tree to 4.9 was, more work than we expected, so it did take a little extra. Hopefully, we are continuing that effort, and we'll see with the next release that it'll be a bit shorter. Just for comparison as well, this is the chart I was showing earlier of the HiKey kernel tree as of July. And this is September after the 960 code landed, so you can see that things have grown, so we've got some work to do. So the benefits to having these boards in AOSP. Well, there's a couple different axes on this. So to Android developers, they get excited because this is an inexpensive dev board that anyone can get a hold of. Relatively to the other devices that they end up using, that has a very small number of board-specific patches. Even at this, we're still kind of much shorter than the multi-million lines of code that we had even at our worst. And it's been able to help them, validate and develop new features for Android. So here's kind of a list of some of them that have been used. And another really cool part is that we've been maintaining support across all of the kernels that we've used. So initially, we had a 3.18 kernel, and then we had a 4.1, although that's been deprecated in the Android trees. And then we have 4.4, 4.9, and soon 4.14. And so this provides one target that supports a wide number of kernels for them. So when they're doing testing for things like security fixes, et cetera, instead of grabbing all these different phones that they know run all these different versions, they can just make sure everything works on this one board the first time and have a lot more confidence in those patches before they merge them. And similarly, it's helpful for their runtime libraries because they're able to make sure that changes that happen in user space are still able to work across all of these different kernels. Another really nice thing about these boards is that they're both capable of running UEFI, so we can get that UEFI is provided in source. And so there's been a lot of situations where we're able to basically adapt the bootloader features to work better inside of the Android environment. And Dimitri's added this boot to RAM feature, which is a nice convenience function that helps extend the longevity of the MMCs. And so this also has been useful for development of new hardware modules for them. Things like the sensor modules, so the Nano HiKey sensor hub is an example, as well as other connectivity modules, sort of like Bluetooth and Wi-Fi. Now, there's been a lot of work at Linaro on the Linux kernel functional test effort, and that's something that's also been something that the Android developers are excited about because this provides the ability to do automated testing on all the stable trees and all the Android trees. And so this is useful to have, and the HiKey board has been particularly useful for that because it's so close to mainline. Now, for me, I'm really excited because, at a community perspective, we're able to do a lot of testing with a target that's an AOSP against a vanilla mainline kernel. So not only do we have those long-term stable kernels that we run, but basically I keep the kernel running against mainline every week. I do a rebase of basically the Mali patches onto the latest RC. And then we're able to use that for testing for all the development I do through the week. And then during the merge windows, I do this basically daily. And this has been able to find a lot of upstream regressions. And so it's one of those things that's kind of nice because when a change in SE Linux stops Android from booting, I can quickly raise that with the maintainers, and that gets their attention and they're able to get those fixed. So we had a number of those cases just in the last 2 kernel revisions here. And this is useful, I think, because it shows we have Android targets and Android-focused developers actively participating in the upstream community. They're providing feedback, they're providing bugs, and it just kind of keeps maintainers from being able to ignore Android as much as they probably want to at some times. And another benefit to this is that by doing this, we also get, I said we're 2 kernels ahead of the current Google Pixel phone, but we're also running on 4.14 RC, and so in some ways that will be the next LTS, and so in some ways we're almost 3 kernels ahead, and so this gives us a really, I guess, advanced view of the state of mainline and sort of what issues are going to affect Android eventually. And so there's been things where we've had new SE Linux restrictions that have shown up that mean that the Android SE Linux policies need to be updated. Things like the DMA buffs code being added and the ION code being moved out of staging was a big issue. And so when we see those changes happen, we see them immediately, and then we have some time to actually solve them before there's even an Android, an LTS-based Android tree that will be using it. So it's really nice to be able to get this work done kind of way ahead of time. So as far as recent and future efforts, so some of the stuff that we've been doing recently, so we were involved in the Android 4.9 bring up and validation, making sure that worked. The HiKey board was particularly useful for that. We've spent a lot of time doing the HiKey 960 migration to 4.9, as well as the migration to Android O. one bit of change that we did is we transitioned to a generic Linux Bluetooth PAL. This is work that Rob Herring and Satish Patel did, and it's really useful because previously we were using a vendor-specific HAL, but now since we reworked this so that we're using basically a HAL that can work with any Linux or any device that's using the standard Linux Bluetooth interfaces. And so this works for HiKey and HiKey 960, but it also works for other boards like the Dragon Board 410. And so this is just nice to be able to kind of create these more generic HALs that can be shared. We also did work to try to make the power HAL a little more parameterized so that it would work across different boards in a more reusable way. And then further work kind of to support Treble. As far as work in progress, Sumit and Laura have been doing great work getting the libion and gralloc support for the new ion APIs. We've got about half of that I think merged, so just the gralloc support's left. So hopefully that'll be there soon. Both internally in Google as well as in Linaro, in Linaro was working on the hibernation proof of concept support on HiKey, and that's kind of moving along. And then also another cool thing is Cadence, who basically made the DSP IP block that is on the HiKey 960, has been working on enabling their Hi-Fi DSP. And they've been doing that just as a community sort of interaction directly with Google. So it's something that's not really been a Linaro effort, but we've been kind of seeing. And so it's kind of cool to start to seeing multiple parties that are not just Linaro and Google kind of getting this stuff going. So the Cadence folks did give some slides. I don't know if they're in the room, but it's okay. So they basically are using the HiKey 960 to kind of develop this DSP SDK that they're going to use for Android. And this is kind of cool because other folks can use the HiKey 960 to test out various applications like this to see if this IP is useful to integrate into their products. And they're going to be doing a demo in the room after this, or I guess in the demo room. And so they'll hopefully be able to see all these different cool demos. They've also provided a roadmap as when we expect this code to start to land in AOSP. So exciting to see that. Thanks. As far as the direction forward, obviously utilizing the HiKey board for upstream-based testing is going to be continuing on. Now that all that code is upstream, it's I feel like its useful life for upstream testing has really just begun. It's so useful that we really want to make sure that the HiKey 960 gets to a comparable level of upstream support, very soon, so that we can start using it for similar testing. Amit Pundir has already been working on the Android 4.14 bring up and validation work, and so that's moving along. So we'll be seeing that soon. Also, Haojin has been working on transitioning to the HiKey 960. It's capable of using UEFI right now, but at the moment there's some polish issues that we have to deal with just to make sure all the functionality that Android expects is there. So we haven't yet transitioned from the HiSilicon bootloader, but we're working on getting that done as soon as we can. And then also, in parallel, we're working on updating the HiKey's bootloader core code to source that's basically closer to the mainline implementation of UEFI. And this way we'll be able to build both boards out of the same source tree for UEFI. And then hopefully we can move on to further improvements like AD updates. Another issue we've had is that we've been using Mali's frame buffer rendering just out of convenience. So we've never really had a proper hardware composer. And with O, we're starting to see problems. And so we need to get a proper hardware composer in place. So we're hoping to use the DRM hardware composer. There's, I think, a couple of independent efforts, both at ARM and Google and Linaro, that we're trying to find a way to collaborate more on after this. I think once we get the, having the HiKey 960 running against mainline is really important because this provides an upstream proving ground for EAS. So we'll have a board that's running, the latest and greatest, being able to have an Android stack running. I think it would be really useful to keep EAS kind of current against the mainline tree. So that would be, I think, very helpful for getting it upstream. We also could work to improve our Treble implementation. It's not great right now, so it's one of those things where I would really like to see the HiKey and HiKey 960 boards be a good reference for folks who are managing Treble or converting their devices to Treble. There's also the accelerated video encoding and decoding integration for HiKey 960. That's in progress at the moment, but we can get that landed soon. And then also, we want to try to upstream a DT fragments and overlay solution that Dimitri came up with for handling the different mezzanines with Android. There's other work inside of LMG that's not connected to AOSP. The generic build, basically this is Rob Herring's work. He's given a couple talks on this. But basically it allows him to have one build directory that's able to support a number of different devices and even architectures with one kind of coherent build system. And so this is really cool. I think it's really useful for finding ways of finding out how we can share better the different howls that we need for various hardware, as well as focusing on kind of finding upstream solutions for driver interfaces that maybe don't have a standard mechanism. But Rob has been carrying this mostly by himself, so it's one of those things where if we can get any more community effort, if you have a board that you're wanting to, a dev board that would be useful instead of keeping your own Android stack, it might be really cool to see how it might integrate with this. Similarly, Rob's work on the generic build has been kind of a baseline that a lot of folks at Collabora, as well as the ChromeOS team, have been using for the open graphics stack. And this is an area I'm really kind of excited about because Google's been nudging people sort of away from proprietary implementations for the graphics stacks like they had with ADF, and towards sort of more DRM and KMS-based approaches. And so I really think it's important that we have a good reference implementation that uses the OpenStack sort of top to bottom, so that other vendors can kind of find ways to align and share more code instead of just kind of doing things their own way just out of convenience. So as far as pain points, from kind of the AOSP developers' perspective, there's this issue that's always, dev boards aren't real devices. They're missing a lot of functionality. So it's difficult to test kind of everything that's expected. They also aren't really product level targets. So basically folks who are, inside of Google are going to be focusing on, the actual consumer devices. And so occasionally changes happen in AOSP that do break the dev boards. Dimitri went through and did some analysis of some of the support effort that he's had to deal with. And it basically comes down to there's an issue every 2 to 3 days that we either have to escalate inside of Google or inside of Linaro. And so it's a fair amount of effort in order to support these boards. And this is kind of a risk as, the issue of scaling becomes a major problem. Another issue is that, the Molly blobs kind of are a bit of a liability. It's really been, ARM's been really great in supporting us, especially through some recent transitions for, O and some of the trebleizing work. But it is one of those things where, with the HiKey board, the GPU on that is getting fairly old. If there was ever a day where ARM decided not to update that blob, the board's useful lifetime would basically end that day. And so it is sort of a risk that we really appreciate their continued effort and support on that. So it's one of those things where I really want to make sure that's, I guess, appreciated. Another aspect is, a lot of work inside of Linaro. We want to try to find ways to share and reuse code, provide kind of reference implementations. Inside of AOSP, there isn't really a good spot for any sort of shared or common howls. We had with the Bluetooth howl that we had, just finding, probably the most contentious issue is just trying to figure out where to put the code, because we had to just put it in with some other project. And it's one of those things where this kind of goes with a more philosophical difference that, folks inside of Google, I think, have, where cross-product dependencies are really avoided as much as possible. Because you don't want a situation where you're updating your device and you end up breaking someone else's. And so a lot of the times they were really hesitant about that. But that also means that for those devices there has to be a lot of copied code, and being able to track mainline projects is fairly difficult. And related to that, this aspect of even just updating project trees, because of this concerned risk, it's very difficult. So for things like Mesa, moving that to a newer version is something that has to be done very, very carefully because you don't want to break anyone who might be using the old, or any specific details of the old Mesa. Also, even just to add a new project to AOSP is a lot of effort and work. And this is, one of those things that can be tough, as we've seen. It was difficult to get the UEFI source added to AOSP, and hearing that the various UEFI projects are deprecating one tree and creating 2 more trees. It's trying to move these trees around is going to be really difficult. And so that makes it harder for us to be able to align with the upstream efforts. As far as the community pain points, the fact that we support all these different kernels is really awesome for the Android focused folks, because they can do so much great testing across all these things. But to actually develop solutions that support all of these different kernels, and the fact that when a new feature shows up in a new kernel, we can't just enable it because we still have to have something to work with the older kernels. It's a lot of work. One example here is with the looking at the DRM hardware composer. There's a hardware composer 2 implementation, but it's dependent on changes that are only in v4.10 and newer kernels. Mersowal at Google was really kind to backport those changes to 4.9. And so for 4.9 and 4.14, that's a potential solution. We can use this DRM hardware composer 2 implementation. But we still need something for 3.18 and 4.4. And so if this basically means that we either have to create 2 different solutions for the different kernel versions, or we have to have some sort of lowest common denominator solution. And neither of those are really great. There's also, and this, to some extent, this is just an issue with being dependent on not fully upstream code. But when we've gone through some of these interface transitions, so the Android sync to DMA buff fence transition, I was really excited. Gustavo from Collabora did a lot of great work moving that forward, and it was very exciting. We were able to validate that work. He also made the lib sync changes to Android so it can support the new interfaces, and we were able to validate that on HiKey. But it's one of those things where it still was very painful. So it had effects through the Molly driver, et cetera, that we had to deal with. We also had the recent work that Laura Abbott's been doing on the Ion ABI changes. It's one of those things where, again, I'm super excited that stuff's going upstream, but it does make supporting multiple kernels very difficult. So it's one of those things where I think, as we push stuff upstream, if we can find any sort of way of making this easier, it might be good. But to some extent, this is, just I think an inherent risk of dealing with out-of-tree code. So as far as for vendors, the pain points that I'm sure a lot of vendors have been experienced recently. So the Treble trouble. So for HiKey, we had the Bluetooth, Wi-Fi, and Gralloc that all needed a fair amount of work. One of the issues we had was Bluetooth was broken for about 3 weeks during that transition, which was just rough. And that motivated some of the generic Linux Bluetooth how it worked. We also had the situation where some of the changes that were required to Gralloc also meant that we needed to make changes into the libgls Molly. And so that meant interacting with ARM to try to get a new respin of the Molly blob. And so this is definitely was a fair amount of complication and stress in order to get. We really do appreciate ARM's effort in getting that respun. I do feel like, I said before, we could have a much better, do a much better job being a reference implementation. This is something I'm kind of looking for feedback on as far as how much folks actually would find this useful. So if anybody has any feedback on that, definitely find me later. So as far as things to watch out for going on in the future, I've mentioned this now a couple of times. So the Ion ABI break is going to cause you pain. It's one of those things. There's been a number of BOFs at this conference, even in talks, and we really do need to get this right. And so far, there's been not a lot of involvement from vendors. I feel like Lauren and Smith have had talks at every conference, for years. And, it's basically the crickets as far as any suggestions to anybody. And so, really, please get involved because, credit Archit at Qualcomm, who gave a talk the other day on some of their concerns. And so we're starting to see a little bit of it, but definitely if your voice isn't heard here, whatever goes upstream, you're going to have to live with. And so it would be really advantageous to get this right. Another part is that, if possible, start aligning with the open graphics stack. Not necessarily, obviously everybody, most vendors don't have an open graphics stack, but where possible, try to see that you can align yourself with the various software components that can use, so that we aren't having to have all these different duplicative interfaces. And if possible, work with the community to see how the upstream interfaces could be improved, or the upstream software, even if it's not at the kernel level. So I wanted then to kind of open things up for questions and discussions. Here's a few kind of things to seed the discussion. So the issues around price versus power is something we want some feedback on. Another issue is that upstreaming boards takes a really long time, and it's one of those things where looking at a couple of different boards, it seems like it's about 2 years to get this done. And so for devices that are fairly long-lived, so things like the BeagleBone, the Raspberry Pis, HiKey, the Dragon boards, this makes sense. It's something that's worth the investment. But for SoCs that might only just have 2 years lifetime at all, it's really hard to convince vendors to invest in that. So I think we need to find ways to, get vendors to, reuse as much of the designs, or try to find solutions that can allow new boards to be supported without a lot of code having to go upstream. Another issue is that, supporting these multiple boards, it's really hard to scale. Going from 1 to 2 is tough. And supporting multiple kernels through that adds to complexity. And so it's one of those things where, as far as there's been a lot of questions of people, before saying, oh, what about this board? What about this board? And, it's one of those things where it takes a lot of effort. So we need to find unique and different things to each board to make it kind of worth supporting them all. Another aspect that I want people to kind of think a little bit about is that getting Android to run on a dev board, that's not too hard these days. But even the vanilla kernel, using that on with Android isn't difficult. But we're not really getting to the point where we're seeing a lot of kind of what's fairly common advanced usage on phones. Things like this offload sensor collections that like the Neon Key can do. There's also devices where when the AP is asleep, the Bluetooth or Wi-Fi can do scanning while it's asleep. These sorts of use cases, we aren't really seeing a lot of code being pushed upstream to support these. And so I think we need to start figuring out what are the right solutions for this, because if we have all of these different little microcontrollers that are talking to sensors, and they all have different interfaces, and it's just one of those things where I think we need to have some sort of coherent upstream channel for the driver for this. I know Bjorn Anderson's been doing some good work with remote proc for Qualcomm's kind of remote processor communications. And so trying to figure out how we can kind of make this coherent upstream, I think, would be useful. And then another issue is that while the Android Common Patch set basically, we don't need much for that to get mainline kernels running upstream. And also the Common Patch that's getting smaller and smaller. Really, the area that I'm seeing kind of more and more specificity from the Android team is that they want more functionality out of the bootloader. And so it's simple stuff like the reboot reasons, or even just factory boot flashing is not super hard. But there's extended bash boot commands that aren't always supported, and there's some of the DTB handling that's needed for Treble, as well as things like secure boot with rollback protection and AD updates. These are all getting pretty detailed, and so every vendor is implementing this themselves in their own bootloader, independently. And it's not really any value add. Everybody's got to do the same thing. There's not going to be one AD update implementation that's so good everybody's going to buy that phone. It's it's going to be just a commonality. And so I feel like there should be a lot more collaboration here. So trying to figure out whether or not we create some sort of a library or some sort of standard reference implementation that we're able to share, I think would be really useful. So I know some kind of work on, some of this is going on with UFI, but there's not much resources. So it's something I think would be interesting to see more of. I guess that's it. Is there any other kind of questions and discussions that folks had?
So you were talking about a generic build. How far away is it an idea that you've got a multiple config that where you actually get one image that can work on multiple devices?
That would be cool. I feel like with the number of different graphics stacks and separate binary implementations for those, it's difficult at this stage. I think the first step that we were trying to figure out is just if we were going to get multiple devices built out of the same infrastructure. So we're sort of at a layer below that. That is an area that Rob definitely is excited in. He basically builds one target, and for things he can boot stuff on QEMU and then have support. I don't know how far you were able to get on the board support. I probably should let Rob answer this one.
We're already doing that, basically. So within an architecture, one build boots on multiple boards. Mainly it's if they're supported in Mesa, then we can boot on one, or use software rendering. We can boot on any board, essentially. Right now it's the common build is not worrying about the kernel side, so the kernel is kind of a separate problem, and that's depends on how close to mainline they are, and if you want to merge all the support patches in together to a single kernel, then you could also boot on with one kernel.
I was thinking of the mainline multi-V7 and how that is so useful in sort of non-Android boots. It makes things so much easier to just transfer, and you can do a debug on this exactly the same binary kernel image
right
from board, and they see, right, okay.
So I boot.
Much easier.
I boot on all the boards I have and have time for, which is, if I had more boards, I wouldn't have the time. But, Raspberry Pi kind of works. It needs some more work in Mesa for Android needs. There's some issues there. The Dragon board, 410, getting the Dragon board 820 was add the 820 firmware to the image and build the landing team kernel for that. So it was basically trivial to do. And we can also do QEMU runs using Virtual for the accelerated graphics using those.
So yeah, as long as you're on that open graphics stack, it's possible. There's other complications that we still have to figure out for things. Right now, the powerhouse are all very tuned per device, and so we added some functionality to allow the powerhouse to be parameterized, but you still have to get that data from somewhere, and so it can't be totally generic, in that sense. So those sorts of problems are difficult still.
Or you just don't have a powerhouse.
Any other questions? Comments? Who's got one of these boards in the audience? 1, 2, 3, 4, 5, 6. Okay, slowly people are coming up. I don't want to admit to it right off.
It was a real pain to get it automated in 916. It was a very difficult process.
Yeah. Here's some more.
Well, we covered a lot of the details of the 960 process when we're actually going through it. There's a lot of documentation of how the UEFI stuff was very difficult to get it right and get the actual board started up. But so far, I've only got 2 960s that I can run any test jobs on, and so far it is looking to be a decently reliable board, but as such a small sample, they cannot make any promises on what happens with your actual variance. So yeah, we are looking at how we actually make the rest of the 960 board infrastructure more reliable for these kinds of things. It's a long way to see.
The kernel stable branches support is to be extended from 2 years to 6 years. So what do you think the impact of that is going to be on the Android kernel?
I worry that it means that I'll never get to move past 318, but I mean, I don't think the 4-year or the 6-year commitment was for that kernel. Yeah, so I don't know. It may just be that these boards become, useful test beds for that long period of time. But it is surprisingly long amount of time. I suspect we won't get away from those kernels, at least the 4.4 and 4.9.
Do you think it could encourage people to upstream boards because the stable branches will be live for a long time? So,
I mean, I don't know. It's so hard to get folks to a comfort level of the idea of moving up to a newer kernel. And so the idea of upstreaming when they're on an old kernel doesn't always feel like a lot of value. Now, the idea that the upstreaming of this board support helps them in their next generation SoC, that I think has value. And it's just one of those things where it's not always the case. Often you get a next generation SoC and everything's different, or at least the drivers seem to be copied in a way that's not easy to upstream. And so yeah, it's hard. I can't. I don't think we have a situation where we can promise folks that this is always going to get easier, which is tough. But it does have a lot of value. I mean, it's one of those things where it's nice because there's a number of boards now. I feel like I think they're mostly all Mali boards. It's one of those where there's a lot of them that are all running upstream. I know the Dragon board's a good example. It's upstream of 410 as of 414, and so I think the ARM ecosystem in that regard is getting a lot better right now, and I think we're going to see a lot more benefits in the testing and the validation side of things. And hopefully that will get people to feel more comfortable about migrating from kernel to kernel. But I guess that's it. Thank you so much. See everybody in the demo room.